Welcome back to my channel. I am Mustafa, and today, the lesson of this day, we will talking about how we can check the normality of distribution of our data. First of all, as we know, many of statistical analysis, including, for example, regression and the parametric test for comparing between means like analyze of variance like ANOVA or test the student, assume the distribution, the normality distribution. So the validity of this test is depends on their distribution or their normality distribution. So this is an important assumptions we should take into consideration because this all of the reliability and the interpretation depends on their distribution or normality distribution. But there is an important things we should take also into consideration, that if the size or the sample size of our data is greater or more than 30 or 40, there is pretty good chance that our data uh, be able to or seems be normally distributed. Let's get started. First of all, we should have these three packages. Tidyverse is useful for organization and manipulation. ggplot makes the plot more beautiful for publish, and statics uh, helps or offer simple way or simple function for calculating statistics and helps Tidyverse working. So first of all, we must, for example, or we have a data frame that's called iris. Iris is a famous data frame. We take or we write it like that using this function head that shows the first 6 rows. Iris have 6 or 5 columns. 4 of them is quantitative variables and 1 of them is nominal variable. So if you want or we want to check the normality of, for example, this variable which is sepal length, we should only, for example, it's necessary to write it like that. First of all, we should put iris like that, percent more percent or more than percent, and then we write the function which is Shapiro upstairs test, and we write the variable into appropriate variable which is sepal length or sepal length, and click to run. This is p-value. This value, which is 0.01, refers to the output of this test, which is represent that the sepal length, which is the variable included in the data frame iris, follow a non-distribution, non-normality distribution. That means we should take, for example, another kind of test for comparing between mean. In this case, we should take or we must take non-parametric test, for example, like Wilcoxon or any other kind of non-parametric test. And if we want to check the normality of each group of species, for example, if we want to test the normality of sepal length in the 3 groups of species, it's important to write a command like this, percent more than percent, and put group by like this, and we should write the species which compounds for 3 types of species, and also percent more than percent, and write the Shapiro function test and select the appropriate variable, in this case sepal length, and put a run. Sorry for that. And click run. So in this case we must have the output. In this case, we have group Setosa, versicolor, virginica, which refers to the three type of species and their p-values. All p-values is more or greater than 0.05, which refers to that our data, our sepal length is follow normal distribution on the three type of variable independence, which is species. So we can conclude, or we can assume the normality of distribution. This is all of our lesson. Feel free to, if you have any concerns, flag any concerns immediately, and feel free to wondering me any question in the comment below. And thank you for your, and I appreciate also your patience. Thank you very much. Bye bye.